1, we are live. All right, welcome everybody to tonight's class. It is the 7th class in the series of classes for SQL 101. This is storing and managing data. So particularly the focus is going to be tonight storing and managing data in the enterprise. So if you go to an employer who has a BI architecture and a BI setup, these are some of the terminology you will hear and see there, some of the technologies, and really how data flows all the way from a system over to all the intermediary steps, how it's stored, how it's transformed, how it comes out of the system, and then all the way down to finally the end user. I think this lecture will also show you an appreciation for how much that there is underneath the covers to actually do to get to that point. And then part of this, then the final part of this lecture will be, like I said, enterprises that have BI programs. There's some other best practices as far as data quality, data management as far as data quality or data stewardship, data governance, data dictionaries. We'll cover all of those, and really both of these together is how business intelligence works within organizations. All right. So how's this class structured? So hour 1, we already took the quiz. We'll do a enterprise data overview. We'll talk about ETL, which is extract from systems, transform it, and load it into your BI system. And data storage, how data is stored within an organization. And then data management, and then database administration. So the difference between someone who manages data and a database administrator. That'll be the first hour. The second hour, we'll talk about programs and best practices within an organization. So data governance and stewardship, and we'll also lecture on data quality. Then the third hour, we'll review homework 3. I've worked on simplifying it, so it's a little more practical for a data analyst, not necessarily designing ERDs, but being able to read and interpret those within a database. And then we'll also do an example with data quality and data dictionaries. This will be on the consoles data. And then we'll look a little bit deeper into extract, transform, load pipelines. And then by the end of this, hopefully load the consoles data into Tableau for us to be able to use off of the ERD. Right. So the last class, class 6, just recapping that from last week. So transactional versus analytical processing. I think we have a pretty good feel for that now, especially from the quiz. That's just a difference between capturing transactions for a system versus designing the database, a relational database, to capture transactions from a system versus designing a database or tables in a relational database for analytical purposes and processing. So database modeling techniques, we have a couple of these. So the ones that we focused on related to relational databases is entity relationship diagrams. These are the high level attributes and entities and relationships. And their relational database model is the lower level. So like the physical, like data types and keys and column names and everything that goes into the database. And that's derived from the entity relationship diagrams. Your normal forms, first normal form and second normal form, it's how you can make sure data is well formed and then decomposed into a more efficient manner that's less prone to update errors or being corrupted, would be your second normal form and third normal form. And then we took a deeper dive into OLAP, so dimensional data modeling. Did a couple different ways that you can structure analytical data. Right. So class 7 objectives, as I opened with, it's really like how organizational data flows is what we're going to talk about. Some of the programs, data management and administration, data governance and data quality, then data dictionaries. But first, we're going to start with data storage terminology. Just like we did with SQL class, there's a lot of lingo that goes into data within an organization, and making sure everybody knows this lingo and understands the different parts of organizational data and how data flows through systems into your OLAP type database structures and then out to the end users. All right. So there are a couple of different types of enterprise data. So all business enterprise have 3 variety of physical data located within their numerous information systems. These varieties of data are characterized by their data types and their purpose within an organization. So we've covered OLTB quite a bit. Describes the business events or the transactions of an organization. The analytical data supports decision-making, reporting, queries, and analysis. So decision-making, whether it's reports or dashboards, reporting and queries, and analysis. So even like market analysis or doing forecasting or potentially even AI or machine learning for the analytical data for analytical purposes. Usually referring to business purposes or business performance, but it can also be for other purposes too. And then master data represents the key business entities upon which transactions are executed and dimensions around which analysis is conducted. So master data, if you can think of it this way, is kind of like an overarching data it's data management that holds the key or the standards for these things in your organization, like what are your customer names, what are their locations, what are their addresses, who are your customers, a lot of entities that you want to be standard across all of your data sources and systems. Well, this isn't really too big of a deal across 1 or 2 systems. If you have 50 different, there are organizations with even up to 50 different systems. Trying to keep that consistent across all the systems can be really challenging. And then you might ask yourself, well, what version of customer do we use for doing our analysis? Is it out of our insurance system, or is it out of like our customer relation management system and so forth? Or even if you're doing this across, one of the examples I would use is we had master data for insurance codes for oral surgery, and you would maybe be shocked at that there's not always consistency across practices or systems on the codes they use, or definitely not how they use different codes for different procedures. So master data management is the effort to try to standardize your data across all the different systems and analysis. So it's a large effort in managing enterprise data. Right. So data storage technology, this is where you're going to start to become familiar again with relational databases. So talked about OLTP, focused on the operation of a particular system, and goal is to capture events. These are often your data sources, all of these different systems. they're producing OLTP data, whether it's CRM, e-commerce system, legacy systems, sometimes external systems. So maybe you use what's the name of that e-commerce system? I don't know why I'm like drawing a blank on it. Shopify. Maybe you're using something like that in your organization and you're bringing it in, or you're using QuickBooks. Maybe that's an external data source. All of these are being brought together by something called ETL. We'll learn about that in the next slide. But you're extracting data out of these systems and transforming it and loading it into what's called your operational data store. So this could be a data like this. I've seen this as a data relational database. Sometimes it is still a relational database. Now, oftentimes it's a data lake. So a data lake is really just a big way to, like a file store almost, being able to store data for use later out of each one of these systems. So in other words, ODS pulls together data from multiple transaction processing systems and sources. You usually clean it and normalize it here for analytical purposes. So you're starting to think you're loading it out of the system and preparing it for analytical purposes. So your OLAP systems, which would be your data warehouses and your data marts. You may hear data warehouse in your organization. This provides you the capability to analyze data in a quick manner. Because imagine if you didn't have this data warehouse, you may have to pull data from a number of different systems just to be able to analyze it. So consider this a way to really store and manage data, like we talked about at the beginning, specifically for analytical purposes. And then master data management, like I said, it manages the consistency of data across systems. So if you're bringing it in across all these systems, you're like, what is a true customer record, or what is a true location record that's contained in, or what's the true billing codes or the rules behind it? That's all master data management. Only when you've done all of that is it ready for what I call a semantic layer. So taking that data and turning it into information that the business can use. So you can do, once you have this information, you put it in BI tools, reports and dashboards, or other types of information delivery. Maybe it's flat files, maybe it's through Excel, whatever it might be, and then all the way out to the end user. So when I say that sometimes a job is underappreciated, I'm usually referring to all of this that goes on under the covers and on all the SQL and relational database work used to clean up the data just to get it to this point. Because this is usually the most visible to the end user, not so much this large effort underneath of it. So that's also where they say a couple lectures ago where we looked at data scientists and what their least favorite job to do is. It would also be this part. So it takes a lot of understanding of systems and bringing it together, and data wrangling and cleaning, storing it and querying data, just like everything, all the skills that we've learned in this class, just to be able to get it to this point, get it to like the exciting point where it's making a difference or an impact in the business. Okay. So that also gives us an idea how data flows within an organization. The process that has typically been used to help data flow is ETL, so extract, transform, and load out of your various data sources and systems. So ETL is a key component of data engineering workflows. allows organizations to integrate, warehouse, and extract insights from many different sources. It helps get these out of the OLTP sources in these and transforms them in a way that they're being able to be used for analysis in data warehouse, operational data store, then data warehouse. So extraction is pulling data from a source system. I mentioned a lot OLTP systems, which is a lot of where you get your data, but you can also now get these from spreadsheets. You can get it from web services, so you can connect to eBay's web service and get pricing information. Like, data is not even really limited to transactional systems. It could be Excel spreadsheets, pretty much anything that you could collect and use for data. So we have transformation. So once you have extracted that data, it goes in order, you transform it. You convert data into the original format, in a format, from that original format that you receive into format suitable for analysis. Involves all the stuff that we did 2 classes ago: cleaning, deduplicating data, combining multiple sources. All of those are true. Those are what create your analytical data and your true analytical insights once you're able to start seeing across. Where you don't see just one system, you start to see data across systems or spreadsheets or web services. And then you load it. So you would load it into an operational data store or data warehouse, or sometimes now a data lake. You insert data into a destination system. Inserting that data into a destination system after you've extracted and transformed it involves mapping the transformed data to a target schema and validating data. I think that is just one of the things that takes the most time, is mapping data from a system to like another system or a target data warehouse. So mapping customers, mapping locations, mapping billing codes, mapping and emergency code, emergency codes, or mapping products. If you have a huge product catalog, you're mapping. One of the things I've done in the past is mapping cellular phone accessories to the wireless device that they belong to. That can be just, if you have 40,000 products and 50 different phones and all the different combinations, it can become a huge task. So that's where a data analyst or a data steward would help with the data and try to map it and try to make it into analytical sense. So after that is done and you have it in the data warehouse, that's where we talked about it going to data marts, where this is where data warehouse and data marts, you're often querying that using SQL. With your SQL skills, these are often relational databases that you can connect to these other BI tools, the front end, and where business users are getting their information and data. If you're a data analyst, you're typically working right here, data warehouse and data marts, whereas a data engineer is often working from a data lake or both. All right. One slide before, I believe this is I have 2 more before we go on break. So I want to explain the difference between ETL, extract, transform, and load, versus ELT. Don't be too confused by them. They're the same thing. It's just that you're doing these in a different order. One's extract, transform, and load, versus it's kind of a newer method to start doing ELT. So ELT is extract from a system and then just load it into something like a data lake and then figure out the transformations later. So this is ELT starting to become more and more popular. This is just really a recap of ETL, the extract, transform, and load. What ELT is is that you're doing load in the second stage. So imagine you're extracting from these systems, you're just loading them into a data lake. You don't even necessarily, your staging area would be kind of a data lake. And then you're just transforming data into data warehouses or for analytics or for analytical purposes, or into a data warehouse or for machine learning or other analytical purposes. The advantage of that is that you don't have to do all this work, as much work to predefine your data. Oftentimes in an organization, data is coming in fast and it's changing rapidly. So even defining it up front through ETL can be difficult, or the business rules change, or the data profile changes. So there's been some movement, especially with rapidly moving data or data that's real time or changes frequently, to do ELT and define those transformations later. All right. So last slide before we go to break is data management versus database administration. So we're going to start talking about data management once we come back. So as you can tell, there's a lot that goes on under the covers. I always like to think of things in three ways. With data, or technology. It's either your people, it's a people effort to be able to do things. It's a process. Your processes help you be more efficient or process or automate. Or it's your technology that helps the people and the processes. Or your technology is some type of specialized, whether it's a relational database to hold data, or it's a BI tool like Tableau that helps you do things more or data and helps you do things more effectively. What data management is, it's actually a huge people effort also on top of technology and process. So ETL would be like your process, Azure Data Lake, and some of the other technologies in Azure Cloud. Maybe those help you with technology and pipelines. People are a huge part. People really have a say in how data is defined and used within an organization. So what is data management? Data management and data, it's also called data stewardship, is the practice of organizing and maintaining data processes to meet ongoing life cycle needs. It's often policy around the creation, storage, processing, archiving, and the destruction of data. That's really important in a bigger organization. Imagine that you've created a lot of data, and you want to figure out how you store it, how you archive it, and definitely like destruction. Maybe you have to do it after a certain amount of time for compliance reasons. Like with credit information, you have to do it after 7 years, no matter what. That everything about somebody's credit history is irrelevant after that. Like having those type of policies for not only like security, but for legal reasons, or just being able to have that history. Maybe it's relevant data, or some business rules changed at a certain point. Like having policies around like how that change in a big organization can be a big deal. What is database administration? So there's a role of database administrator within organizations. We briefly talked about this before, but it's really a person who's technical in nature, who focuses on specialized software, usually relational databases, to store and organize data. So they're really down like in the weeds, I guess you would say, of making sure like the configuration, design, migration, the security, backups, and data recovery of a database systems are all working. So like the things that just need to happen to keep the lights on a database or some other type of storage. And then to be able to monitor the performance, to be able to make sure it, you have the best performance and you're able to access the data. So database administration is really less about, well, it's more about the technical aspects of storing data as opposed to like how data is created and managed itself. So database, they do both have similarities in the sense that both the specializations coordinate the database planning, the goals, design, and communicate actions while the project is being implemented. So a database administrator may very well be involved in if you create an analytical data mart, helping you draw up those diagrams that we looked at and be able to implement the data mart that you need. What's the difference? So data management focuses on the logical design, like the planning and organization and design of your analytical databases, and then just overall these manage the just some management and the policies around data overall. Database is the focus, the physical design, so performance, storage, access. They really don't care as much about the significance of the data that goes in or these policies. They just worry about their system being able to handle it and run it and being efficient for it. So I would say database administrator is a very focused technical role versus there are actually multiple aspects of data management that we'll talk about in the upcoming hour. So all related to just data and SQL and how data is managed and flows within an organization. All right. All right. I'll give everyone about a 10-minute break. We'll come back at, let's see, let's do 7:15. We'll give everybody 13 minutes. And then we'll talk about some of the policies within the organization. All right. See you in a few minutes. Right. Hope everyone's refreshed and back for the second part of lecture. We'll get started. All right. So at the end of last hour, we led into data management inside the organization, and it being largely a people effort with coordinating different people whose roles are creation, like policy or DBA, the storage of data. They're even different, like roles in here, people who management data, data administrator, or data, like your data stewards or your so forth. Even sometimes business management process managers have a say in defining data, because oftentimes the process that data is generated through will define or will influence how data is defined in an organization. So the second hour is really like not just the technology and the process, but the people related portion of data and data management and storage and policy within organization. So data governance and data stewardship. We talked about data stewardship a little bit. Theirs is a position that ensures data governance processes are followed, guidelines are enforced, and they recommend improvements to just overall data itself and data processes. So I skipped it a little bit, but data governance is a quality control discipline for assessing, managing, using, improving, monitoring, maintaining, and protecting organizational information. That's a lot. What I have seen in my experience, only the largest companies have data governance groups, but data governance can be very important, especially if you're generating data from all these systems, in defining like how that data is used, the quality of data, how you monitor and maintain it. And then the data stewards, like I said, they work alongside the data governance team who creates and enforces this policy to make sure that business users are following those guidelines. And they're the people who, data stewards are often people who really know the data and the domains so that they can help the data governance team make policy. Well, here's a wheel of data governance, kind of like everything that data governance touches within an organization, and is also influenced by data stewardship. So all the way from like data architecture, how you store data, the security of data, reference and master data, how things are defined within the organization, policies around data warehousing and business intelligence and the use of analytical data, and even metadata. We'll see like data dictionaries or data glossaries or things like that to be able to like define data in the organization and define metadata in the organization. So bring this to awareness is like SQL is a part of it, but being able to obtain data within the organization, but often data in an organization is also governed by all of these, in large organizations at least, governed by all of these policies. You may work at a smaller place where there's a team of 2 or 3 people, and essentially they do a lot of this, or they're the decision makers for this. But if you work at places here like First National Bank, or yes, ConAgra's not here anymore, but Union Pacific or Blue Cross Blue Shield in Nebraska, they have these type of teams there to help manage the data in those organizations. And then as a data analyst, it's up to you to follow some of these policies. All right. So one of these is measuring data quality. So what is data quality? We saw In last week's lecture about cleaning and cleaning and formatting data, is that sometimes data is really messy. Like there's a field in homework 2 where there's a whole bunch of data compacted into a single field, like appended into a single field. This is like something that's really common out of systems. So sometimes there are errors or incorrect elements that are present in your data set. It's important to be proactive in cleaning data and periodically testing it for inaccuracies. So data quality is really like the measurement, like putting measurement metrics around it and then testing it to see like that the systems or whatever manual entry or whatever place is maintaining a certain level of data quality. What is a data quality assessment? So you can identify these errors and understand their implications both by qualitative assessments and quantitative measurement. So often this quantitative measurement is what I was just talking about. The qualitative assessment, some of that is just exploring the data and seeing errors and seeing that things need to be fixed. It'll improve data quality processes for quality and effectiveness. So what is an example of measuring data quality? So data quality metrics track how the number of known errors in a data set. They'll track the number of known errors in data sets, such as like missing, incomplete, or redundant entries. Sometimes they'll also be invalid entries. If fewer errors, so it'll be like, I've seen this where it's like the data set, you give it a score of 80%. It's like 80% good, or only like 20% of the records don't have any errors or anything wrong with them, or 90%. And then there's like a certain threshold that's set before you need to fix things. So fewer errors. So one of the things to keep is that you can track these metrics. And the fewer errors that you have while the size of your data stays or grows the same, you know that data quality is improving. Oftentimes, data in an organization just keeps getting bigger and bigger and bigger and bigger because systems are generating it, or you add multiple systems or data sources. So if you know relatively that's staying the same while your data grows, you're putting some good quality or processes or checks in place. So quantitative measurements, the different things that you could do is look at whether the data is complete, whether it's consistent or accuracy, some of these things that we talked about before, validity, uniqueness in records, how many like duplicate values there are. So all these are data quality dimensions. Here's one that's an additional one, so timeliness of data. So does the data actually make it there when it's expected? This is a bigger issue than you would think, because maybe you're pulling data from a system and the system's down, or it's transmitting slowly, and then it's not available for the next day, and then the alarms or the sound about not having data for the previous day. So you can actually measure that to see if it's a problem, and then recommend some type of process improvement to be able to help either this metric or help other data quality metrics. Without any data quality metrics, you're usually just chasing your tail from one issue to another. You'll see, and say it's sometimes it's a system, sometimes it's somehow somebody manually inputs something. It could be for any number of reasons, but it's always ends up, if you don't measure it, it's an end user who usually recognizes it and then points it out, and then you have to go research it and clean it up. And it may be like a never-ending battle, but with data, it's always something that you have to maintain anyway. But these data quality metrics would help you point in the right direction, or what's wrong with specific data sets, and being able to have those processes to be able to manage it and fix those issues a little bit better. All right. So there's data quality using Python. Why I wanted to show you this is that there are Python libraries that you can do all this in SQL. You could create a bunch of rules and measure it. And in the next class, we'll learn about stored procedures, which is basically you could store a whole bunch of SQL code together and do it in like a series of checks. But until then, I'll show you how you could do this in Python, because there are a number of libraries that can help you do this task. One of these libraries I found is called PyQDC, so data quality checks. It'll help you measure, will help you with the following tasks: data integration, cleansing, monitoring, auditing, and investigating unknown data sets. So data integration all the way from pulling it from systems versus a expected schema, and then being able to clean. Monitoring is a big one, so being able to alert you to issues or tracking those KPIs and the quality KPIs and alerting you to issues, or data auditing just in general, being able to go in and look at the issues. So the library allows the user to load the data by pandas data frame, infer the data set schema, and generate a summary of your data. It's really cool. I just want to show it to you quickly, just to give you a feel for what data quality looks like. I won't expect anybody to write any Python code or anything, but this one it's kind of nifty. So there's this GitHub library, talks about what it does, aims to relieve the pain of writing tedious code for general data understanding, which it definitely can be if you're trying to track all the issues within a big within mountains of data. So what you can do is automatically generate a summary report, summarize statistical differences between two tables. This one would be valuable as if the profile of a single table changed quite a bit, like all of a sudden you're getting a bunch of new values in there. But yeah, of course, you still need people to look at the results and interpret the results, just like you do as a SQL or a data analyst, being able to interpret the data and really understand it, to be able to not only just pull the right data in the case of SQL, but be able to interpret it and help others make the right decision, interpret the data and make the right decision. All right. So it gives a high level overview of what it does, but what it first does is give you a data schema, so it profiles all of the data. By column, it will give you the type and some of the sample values. Then it gives you a summary of data. It's like a frequency of how often each one of these happens. You can see one of the things you want to do in data analysis, especially if you're doing like machine learning models, is being able to profile the data to see what you're putting in the model and what your values are going to be. You could look at dates, numeric values, compare data between two data sets, see frequent string values that occur. This one's really good, especially if you have a lot of null values that are occurring, or if you have outliers or something like that. So consider data consistency, check consistency of the same columns between two tables. All sorts of stuff, both useful for data science projects and data quality checks. Because if some of these happen, you start to see a bunch of outliers that are being produced. You go and investigate like why the system's producing those. And it may be something that you have to change within the system. It may be change in the data. but you catch it ahead of time and you can make that recommendation. So I would say that's where you can come in most valuable as a data analyst, not just by writing SQL queries, but really like knowing the data and knowing the systems and why values are being produced, and then helping end users or developers or whoever it might be, like fix these issues with processes or help fix data quality issues that lead to better analysis. So not just being somebody who pulls data or has that technical skill, but being a true analyst who knows the data and is an expert and makes recommendations. Right. So data dictionary. A data dictionary is a collection of sources, names, definitions, and attributes that define the data elements captured in the system. Often contains information about names and physical information of all database schemas, tables, and fields, a system of record, so where the data originally comes from, table constraints within your analytical data marts or data warehouses, and then business rules, transformations, and metadata about field values. So data dictionaries are really related to OLAP data structures. So what's really, so if this looks like kind of like the information you would have for a table, you would be correct with that. It's like it can often contain data types and things like that, tables and fields, but it also contains mappings from the very original place that you did it. So this one would be, say you got all these fields from a spreadsheet, but it could be any number of systems. What table you got it from in that system, like, so it really gives the context of the data. Source column, destination column, so the column in your source table and how it lands in your analytical data mart, destination column, and then transformation. So keep in mind those ETL, when we talked about ETL and ELT, oftentimes there's a transformation of the data that happens to get it into where you want for analytical data. So something like this would be a good example. Say your system produces single S or single or married or M for married, and you just map all of those to an S and M, a D or W. That's important to note because it's important to know how somebody put it in the original system and then how it's being used in like a data warehouse or for analytical purposes. Otherwise, you may have to go all the way back into that system and then figure out the different values and how they're, and then re-engineer the process to see how everything's mapped. The data dictionary is like a quick reference to be able to tell you where the data came from, how it's mapped, and what rules were used to transform the data into analytical data. The last one here says it really well: business rules, transformation, and metadata about these field values that are in the analytical data mart and how they came to be. Because even like I said, you could have different systems that have different customer information or marital let's go with marital statuses. Maybe one system records it a different way, another records it another way. Maybe they aren't consistent. Maybe one system hasn't been updated and the other has, or it's only updated like when somebody signs up. So maybe somebody got married and they aren't consistent across systems. So you could tell exactly what system you're getting this from. Hopefully it's up to date, but most up to date. But it could be, for whatever reason, you get it from another system. So the context and the original system in which the data was created is really important. Right. So relatively shorter lecture today. So a review of data storage and data management within the enterprise or organization. Learned about ETL and ELT and the differences between the two. Learned a little bit more about data warehousing versus operational database servers, and then entirely just how data flows in the organization from operational database servers all the way into uh, data warehouses or your OLAP type data structures, and even all the way out to the end user. And then we learned how enterprises and other organizations store and manage data. They store this in these different systems or even a data lake. And then managing it is like really like a large people, process, and technology effort. Maybe even I'd call people as the biggest coordinating factor, the biggest part of it, whether that's access controls, job scheduling, data governance, dictionaries, data quality. All of this, in turn, is what is called business intelligence. So it's funny, like somebody asked me what I do for a living. I tell them business intelligence, and 9 times out of 10 they have no idea what it is, and that's probably rightfully so. With you couldn't really explain it to everybody this way, like all the stuff that you do under the covers and the systems and the data and the processes and defining it. So the simplest way I do it is explain it to people is that I turn data into information so that end users can make better business decisions. And now even some of it's even more than that. Some of the data is real time or getting fed into AI or machine learning models. So I may have to rethink that, but in general, what your role is here is as a data analyst is interpreting that data from systems to use for analytical purposes and like improving decision making within an organization. That's why hence business intelligence here, hopefully making the business more intelligent with data by everything that you do to extract data, manage it, transform it, all using your SQL or other data skills that you have, and taking that data and getting it to where the business can drive better decisions. Right, so a couple of additional resources. In the past, I've done a lecture on tools for data manipulation and management. I'll just bring that up real quick. It's different tools that are used within an organization, whether it's ETL or workflow tools. There are a couple of common ones in here. You can use Python for it, but then there are other tools like Talend and Data IQ for data science projects. That's one that Can really likes to use. There will be a class upcoming actually in cloud and these different cloud storages, but this gives you an introduction to it. NoSQL. So you put no on the front of SQL, it becomes a different way of storing data. So there are different types of NoSQL databases and ways to store data. If you're interested in that, you can read more. And there are a couple of videos in here telling the different aspects of like Google Cloud and stuff. So if you're interested in reading more, feel free to do so. I also did one specifically over Talend ETL. So instead of writing all of your own SQL procedures or rules or code to try to check for data quality or do ETL, there's some automation that you can do through data pipelines. You'll learn more about this type of tool if you end up doing more in in the data engineering track. But this is a tool that helps you with ETL and build in data integration and data quality and so forth. So instead of reinventing the wheel, you have some tools that do it also that can help you out with these type of things. All right. And then ETL using Python. So you can create, I've done it a lot in the past, is create an ETL process or an ELT process using Python. Um, why use it for ETL? It's really flexible. So common for data scientists or data engineers to use it. You have a bunch of libraries, like we showed with that data quality, that can help you connect to different types of files or databases. Um, Processes are known as data pipelines. The only concern that you eventually have with this is that if you write 100 different pieces of code, do 100 different integrations, it eventually becomes hard to manage it, which is where a tool like Talend ETL comes into play. Or if you're doing this all in SQL, all of your data management checks, sometimes just all those data management and data quality checks can become a lot to handle, which is where a tool would come in handy. Which is part of what I do for consulting is recommend tools and better ways to do things for um, different organizations that are doing business intelligence. Right. That is it for this lecture. The next lecture, I don't know if I have a slide on it, but it's going to be about the next lecture is um, advanced database functions, which will really be about uh, procedure, or the standard SQL is what we've learned. We'll learn more about procedural SQL and like stored procedures, functions, and creating your own functions and triggers. So some of the things I talked about in class today that could help you do some of this data management, or just help you write routines that you can reuse. So that will be the next class. And then we'll just take a really short break before I talk a little bit more about um, the simplified homework and what we do for the class exercise. So take a 10-minute break. We'll come back at 7:55 and I'll explain the homework assignment and ERD diagrams and taking a closer look at class exercise for today. All right, see you in 10 minutes at 7:55.
Like last summer, not last summer, the year before. Like
All right, everyone, we're back from break. I'm going to start with a revision to homework 3 for class 6, and then we'll talk a little bit more about class exercises. So, initially, homework 3, there is quite a bit in it as far as identifying with ERD work and then converting that over to OLAP and then defining all these relationships. It was really a pretty big effort. So, what I really think is important to take out of it, and just thinking like a data analyst, is that you're able to identify the different parts of a database schema, like an or entity relationship diagram, and that you're able to take a look at a relational model and then say, how can I go get my data from that? So what I've done is really a simplified version of homework 3 that I'm hoping will help everyone out. I've given you a diagram with an ERD, and I didn't define all the possible relationships, and I related all of these others with game as the central table for this. So for the first one, a couple of you have already done this. Name the entities, attributes, and relationships. The ERD diagram is created for you here. Now you just need to take this, convert it into a relational diagram in using diagrams.net. And then within the homework, I've also provided, you noticed I provided a bunch of views. What this is a view for each one of these ERD diagrams, or for each one of these entities in the ERD diagram. So what I would like to do, what I'd like eventually is for you to build these and then just practice querying around this diagram to be able to get different information out of it. So I think for a question number 5, and I'll resend this, is just answer a question that you would like to know about out of this diagram using these views that we've created, based on this ERD diagram. So 3 things. So just to recap 3 things. Do number 1, name all these entities, attributes, and relationships. Then use this. Number 2, use this diagram. Now this is basically number 2, to create a relational model, kind of like that physical diagram of how you would implement this within a relational database. And then 3 is build these views and then write a query based on this ERD. Does that, Melinda, seem a little more straightforward?
Yeah.
Or is anybody else, does that help everybody else who's doing on the homework? And I won't have this due until Friday, so we'll let this one go past the final, and then I'll grade these as late as this upcoming weekend to include with how you did in the class. Does anybody online have any questions? I think, Melinda, you were going to ask a question. Maybe. Does that help simplify it a lot instead of having to create all these relationships yourself? Because Rosendo said the same thing. He was like, if you did like all the different relationships, how like overwhelming that would be between the.
Because if you would do it for every, so like, for instance, there's 4 tables, and they almost all of them represent, say, a name in different ways. But then, like, that would connect to something else, and there are different ways. So you'd be connecting every single, like, column name to another column name to another, like, that's where I was like, a lot. That's
Yeah.
a lot.
I think giving you the ERD simplifies it a lot.
Yeah.
That this will simplify your relationships in the model that we create, and then help everybody with the rest of it. The SQL code is based on this ERD, those views. So you can build that in your own schema and then query around it to answer some of your own questions. That really gives you a feel for like, what is this diagram? What does it look like? How is it implemented in the database? And like, then how can I query around it and use it? You can see I define these relationships. Like a game can be pre-ordered. A publisher or a game is published by a publisher. A game or a console plays a game, and so forth. Anyone online have questions, willing to take anything in Slack or otherwise? I will resend this with a question number 5 just to create a query for 2 using these tables. I'll resend that in the morning tomorrow, an updated homework template. No questions from anyone online? All right, going on. Of course, you're always free to ask me questions on Slack. That's actually when people started asking me questions on Slack, me realize that the last homework may have been a little much, and thinking about the goal and what you really want to get out of it. So I'm definitely responsive to any questions on Slack. Just let me know if you come across anything. Happy to answer questions about it. And then due Friday, and then I'll have feedback and results to you by the weekend for both the final exam and this homework. All right. So let's go ahead and do a class exercise today. So using this same ERD, I just posted 2 files inside of Slack. So one of them was a data dictionary related to this console data, just for you to become familiar of what a data dictionary may look like. So not really as much as an end of an exercise, just to open it and look around and explore it. And then the same with data quality is I sent you a piece of code just to see how you would use this library in Python. You don't have to run it or anything. Just look at it. Feel free to ask questions. I did put data quality by using Tableau. So what I've done in the past is profile data using Tableau, and just to get a feel for what columns and what values look like. And we'll do that as an exercise here tonight. But first, what I would like to do is everybody let me know if you already have Tableau and you're able to use Tableau Desktop, because I'd like to connect everyone to those views that are already created, and then you can get these in the console schema. So the game view, the game pre-order, console publish, and so forth. So does everybody still have a working copy of Tableau? If for anybody online, if you do not, please let me know. Actually currently have a copy of Tableau Desktop myself. Have my own license. But when did this year still work?
Mm-hmm.
I don't hear. I don't know. Anybody online have a working copy of Tableau Desktop? Just let me know, yes or no. Bianca does not. Okay. Thank you for that. You have just the public.
Yeah.
So public's like where you log into the portal and
Yeah, but then
use it that way.
you can download it and use it on your desktop too.
Is the license expired for public that you have?
Mm-hmm.
So even if everybody has public, are you still able to open Tableau and maybe not? Yeah, and see this first main screen and be able to create anything. Hold on, it'll pop up here in a second. Can anybody open the application and then see this and create new? Otherwise, so I think you may still be able to do this. So the way I did it is have my SQL down here at the bottom, and I connected to that using my database credentials. Thanks everybody for letting me know if it looks like it still works. Go ahead and try this your database connection. It's I'm gonna paste it. You may not be able to do this.
Yeah.
Oh, it doesn't have any SQL option. Okay. So one other thing that you can do here is if you don't have that option in Tableau, it doesn't seem like you do, Melinda.
No, because the free version doesn't have all those extra
possibilities. I got you. The public version doesn't have like all these connectors in it. Okay. So what you can do is you could download a trial of Tableau Desktop. It'll take you a little bit. And it has of both a Macintosh version and a PC version. It's a little bit aggravating because you have to put your information in, and then it'll give you some download options. But I'll go ahead and record this for everyone. Like if they want to download it tonight, that'd be great if you can do it. But if not, then it'll be recorded and everybody can follow along with it later to import these data sets. Or do we want to just give everyone a few minutes to try to do it?
Is it better to do that, or could you go to Workbench, like download, like pull up your whole table, download it to an Excel file, and then upload it to
yeah, I guess you could. If everybody can do Microsoft Excel, that would be, I guess that would work too. Here. That's a good idea. I don't know why I didn't think of that. Thanks, Melinda.
I have to figure out workarounds.
Gold. 2 gold stars. So I'm going to create this Excel file and just run these views, and then you can import each one of these like a tab. So that way you don't even have to worry about running the views or anything like that. It's in consoles. So I need a new Excel sheet.
Yeah, like for that one just on console, or is it all using all 4 of the ones?
What's that you're saying, Melinda?
Is it using all the 4 from the original assignments, or did you make a new one to go with this like ERD stuff?
Just a new one.
Oh, okay, so yeah.
For the CRD. Okay, so the tables we need for this are game pre-order, game sales, publisher, and console. Let's see if I can remember that. So I'll move this over for just 1 second. So I need game pre-order. In one way, I didn't show this before, but there are 2 ways you can copy all of this data out of MySQL Workbench. You can copy rows with names. Oh, that does it like that. And then do a text to columns. Comma separated. Well, that didn't work great. Hold on. Yeah, you can use export. Copy with rows. Copy row tab separated. That works a little bit better, but you also need the header in each one of these files. That one worked okay. Let's do that. Or you can use the export utility here. You can copy it and do comma separated. Or you can export it as a CSV and then copy and paste it into Excel also. So I'm going to take each one of these. Game pre-order. No, publisher was one of these. If I select all. publisher. That's all publisher is. It's just that table. We also need game. Copy row. This is the one I found that's the best, with names unquoted. That pastes well in there. In that first column, you just have to remove the number sign, and that was game. That's our main table. Game sales and console, that was all of them. Just taking a second to close that. So the idea of this is that you can take the tables from that schema and then look at the ERD and be able to connect all of these tables together once we get all this information where we can use it. Okay, that was table console. Sometimes I put data into Excel just so I can visualize it or see it a little bit better. It can be a little bit harder than just a small screen here. If I paste it in Excel, I can really see like the different rows and the values and everything, the game ranks and years. I really use a few different tools in combination with using SQL on databases. SQL is an awesome tool for like obtaining data from a relational database and automating some data processes and cleaning and stuff like that. But I also use Excel for a few things too. If I want a quick summary of something or filters, do some filters on it. Game sales. There we go. We'll save this as consoles, schema, ERD. These are the views that I created out of that ERD. Diagram. Just all pasted as tables in Excel. So basically the same thing like we talked about in the first class. If you think about relational tables, it's just like Excel tabular Excel tabs. But basically if it's in a relational database, you can structure it and store it a lot better and query it and do things a lot more efficiently than you can in Excel. Oops, I didn't save that. Let's go ahead and save this to my desktop for a moment. Let's see, consoles. Okay, I'm gonna put this in. I'll put this in the Slack channel so we can all use this. So this in its own way makes it a little bit easier than having to make the connection to the database anyway. so many things open on my desktop. Okay, there it is. Let's close that first. Okay, data for ERD, data for class 7 exercise. Okay. Now everybody let me know you should be able to import that, it seems like, with your Tableau public version. And I'll just walk as you're doing that. I'll go ahead and connect to this too. So game was in our ERD. Go ahead and pull this up, or maybe I might put this in a snapshot right next. Need to paste this ERD diagram here if I can. Hold on. Yeah, it doesn't look great. Okay, one more messing around. Let's bring it back over here. I'll try to copy that one more time. So we have a snapshot of it as we're putting this ERD together in Tableau. All right, so we have this ERD that we've created, and we have each one of these. We imported that Microsoft Excel file that I dropped in there, and then we have each one of these tables. So here's how I would go about doing it. We made game our central table that every one of these is related to. And then we can define these relationships one by one. So you can do game pre-order. And that's related on game and game name. Oop, game name was in that one. Game name and game. That creates that relationship. You see when you do that in Tableau, it's like you did a join in SQL. They define that as many to many. I think Tableau by default does a left join on these. But you can also, you should be able to define the relationship here. Oops. Yeah, I'll do that in a minute. All right, so console relationship between consoles and games is by platform name and platform. So click on that relationship. Platform and game and platform name on this. So now we have that relationship formed, and we just do that for these other tabs. that's how we can build this ERD inside of Tableau. And feel free to ask any questions if, as you're doing this, if you have any problems or anything else, any other questions you'd like to ask. Oh, here we go in Tableau. They used to have in Tableau where you do left, right, or inner join, but Tableau defines these differently now. It says how do relationships differ from joins. So I'm interested in this. Relationships are a dynamic, flexible way to combine data. You don't define join types for relationships, so you won't see them in a Venn diagram. Think of a relationship as a contract between two tables. So Tableau, no upfront join type. Tableau first attempts to create the relationship basics on existing key constraints and matching field names. So basically, Tableau relationships can be many-to-many to support full outer joins, which it appears both of these by default are just many-to-many. So this really works well with an ERD to be able to put this in Tableau because these are relationships just like Tableau defines them. Tableau automatically detects a relationship between the tables, which is kind of interesting. You used to define them, but it's be intelligent. And then once you do all of these, so consoles, game pre-order, game sales by title, title, and then title and game name. And publisher should detect that on its own. Publisher and publisher detected that one on its own. Oftentimes, if you're joining two tables together, Tableau will, if it has a common field name, it can detect what the primary key is. You can either extract this or go live. Let's just go ahead and go live. All we're doing is connecting to Tableau sheet. And then you see you have all these metrics, measures, and dimensions that you can use out of Tableau from each table. So we could do North America sales. That doesn't, I don't know if that looks quite right. Let's do platform name. Seems to be missing some information. Let's see what happened with our relationship here. Go to game. North America sales. Oh, because I know why. I thought that was weird that it showed 4,602, but that's in millions. But it should show for relationship. It shouldn't just be that for platforms, I think. Oh, it looks like maybe it didn't. Game. Let's see. And check all the relationships to make sure they actually worked. Publisher one. Oh, that's what. Publisher one isn't in. That's not actually in the same format as the game publisher. Maybe it is. Nintendo. Seems like that should work, but maybe sometimes you may have to go in and troubleshoot the relationship. So let's actually do something different here. Instead of console, let's do this by game title. Oh, that still didn't work super well. Here, let's just do something from game here. So sum of North American sales. Just take from this single table first. Those are in millions, North American sales. Can do this by game year. We'll make that discrete. No, that doesn't make that much sense. So, platform. That's right. Game year. So you can see the game, what platform it was for, the year. Doesn't seem like that platform joins working quite right. Except for the 2600s. Well, I wonder if it's because of the data type. How it's joining and what it thinks the data type is. Say the hard thing about doing this in Tableau is it's just not as straightforward as it's not like how these are joining together and the date or the data types and what's coming together isn't as straightforward as when you do it in SQL. So if I was to do publisher and game, here in SQL you could do select A dot star, B dot star, consoles publisher, or consoles game. As a left join, always do a left join. This is a little bit safer to see what's going on, or a little bit easier to see what's going on where it matches and doesn't match. As B where A dot. So in game it's called publisher is equal to B dot publisher. You can do it as where or also on clause. Let's just do a publisher. Oh, nope, that worked. See, now that worked. That join worked correctly. So it looks like we have a little bit of work to do in Tableau to make that join work correctly. Let's see. Publisher. Looks like it should join the type string. Publisher to publisher. one way to do this that can help is just doing these tables one at a time. Just delete that relationship. Move. Let's do these one at a time to make sure they remove or they work correctly. Okay. Commands are in the first row. So what did I do here? Go back. Oop, those are still there. Move. Remove. Okay, game to publisher. Connected by those two fields. This should be a many to one. Okay. Publisher Nintendo, okay. And you can see we now just have those two tables. Lots of nulls. Let's see if there's a issue with that. Case sensitive. Not quite sure why these two weren't joining together. Usually this is where I'd talk about, I don't know if I mentioned it before, usually before I put something in Tableau, I would create a view in SQL and then do the joins that you want and then just import that view. I think it's easier to edit it at the database level than it is to, you can create these ERDs or these relationships within Tableau, but I personally have a hard time seeing it, or when something like this happens where why it wouldn't be joining together. So usually it's a lot easier to do it inside of MySQL Workbench, and then you connect to a view. You create that code as a view and then connect to the view, and then you import all your data that way. So as an example, well, actually, yeah. I actually want to do this. I have a database version of this that I created earlier where I connected to these views. Let's see if this works. Publisher. And if it's not, it might be something in that Excel file. Yeah, it's something in that Excel file because this is where I connect to the database. And that match or that join works okay. But something with the inside the Excel file was gone wrong. So you could export all of these as CSV files. I might do that and give that to everyone and see if that works. Put that. Let's see, what else do we have here in the homework? So that's the idea, at least, is that I would import those views instead of doing that in Excel. That, or just create all these relationships in one big view. That's also possible. I've created them as 5 separate views where you can join them all together. And then how you create that ERD inside of Tableau. I'll show you one other thing before I go, or before we call it good for the night, is doing data quality inside of Tableau. So here's what I usually do. If I really, to get a feel for the data, I'll do on discrete or on measures, I'll do something like, let's do platform instead. So there's not so many. Okay. So you have all these platforms, and then you could see the number of sales by platform, or just the number of records inside of that, and then the number of records inside of each one of those. So you can see how it's distributed. Console, I don't want to count console though. I don't want to count the number of records in that data set. Make it create. If you do a sum of 1, that's the same as a count. That only did. Oh, because this data set, that's why. Is this data set, it just has 1 record for each one of those, doesn't it? For platform, there's just 1 3DS record, 1 DS, NES. I thought that looked weird. But this is doing this by, that's doing that by platform. And then combining that with game. So let's do this. Platform. Publisher. You can look at the distribution by puzzle or by this and see any outliers in sales. And just see the distribution. Well, we say 1, but you looked at the distribution of a different field, maybe. We did genre. There we go. There's the count of the number of records here in the data set for each one. So it gives you a feel for all the discrete values. You put this. Put this way and sort them. There you go. You can see really quickly, like, get a feel for a data set. That action has the most titles, and then sports, and then shooters, then racing games, and so forth. Maybe you would find that there are a bunch of null values, and you could do nulls or NAs and see that there's a high count of those. Or if they're just some names that you wouldn't expect in here, where you say, what is miscellaneous? You could go dive deeper into those. You should be able to dive deeper into those records. If you were to download the summary, could dive deeper into the records through Tableau to be able to see specifically what's there. Or if you wanted to just see the distribution of certain values, I'll call this one. Let's say we want to do NA sales by platform. Then we wanted to do this. You can do this a box and whisker plot. Say there are a couple with 0, like what falls in the bottom quartile or the lower hinge, and then what ones are really like the outliers. Or overall. So really like looking at the distribution of values, looking at any null values or outliers, or possibly you could look at duplicates too. You could do maybe we don't want to do that in that one. There are no duplicates in that data set, but if any of these were, if you expected there to just be unique records on platform name or some ID, how about let's do a better example. There's a duplicate here, alien versus predator. You'd say, well, why is that? Maybe you might have to go into the data set, show fields. Oh. Let's go back into the original Excel spreadsheet. Oops, wrong one. So I don't have it open anymore. Okay, so if we go into game, let's try to find alien versus predator here just by filtering these results. Aliens versus predator. Oh, there might be an error there. Oh no, it's not an error because two different platforms, same game but two different platforms, released in 2010. So I really like Tableau for exploring the data. I find it to be a little bit easier than writing a bunch of queries to find. Well, it's not that hard to find duplicate values in SQL, but just like wrapping your mind around data and seeing what values are in each field and the counts and the distributions and numbers, which is really hard to do with just doing SQL. You can really explore it in Tab. You can write the code. You can write your code in SQL and then import it into Tableau, create the relationships if you need to, and then say find things like, oh, why are there two aliens versus predators? In here it's because two separate platforms, PS3 and Xbox 360, both the same name, same year, of course. But that might actually, yeah. You can see the distribution, or just see all the values in genre and how many there are in the data set. I will also tomorrow export these tables as CSV files. So if anybody wants to put those together in Tableau, that they're able to do that. I'm not sure why it wasn't working out of the Excel file that we created. It's something related to Excel and how we're copying and pasting. Anybody have thoughts or questions or anything leading up to our last class? Hopefully it's simplified homework 3 here a little bit. Don't forget to do 1. Right. Write queries using the ERD to write SQL queries. Answer game related questions. Don't forget to do number 5 and just write maybe 2 or 3 queries, different queries that you find interesting using the ERD. And I guess no luck probably either with the Excel sheet.
I would see my connection, but I can just put my color. Other thing.
That's okay.
To kind of see how
I'll try to work on CSV files, like I was saying, for tomorrow, or that work. They'll import and export cleaner than copying and pasting into Excel sheets. Whatever could go wrong with pasting can make the difference. It's the life of a data analyst or a BI developer. It's figuring out why an Excel sheet won't import properly. All the under the scenes work like that.
I mean, there's different spreadsheets going to different places, and that's what they're trying to compare each other. And I guess that's what we're trying to compare versus it just being one spreadsheet. Yeah.
What's that? You're
No, I was just saying that and then
yeah.
I realized what I was saying. I was saying like, no, that's not what's happening.
Sometimes I do that. I have to say it out loud to think if it makes sense or it doesn't make sense. I have to hear it through my ears. That's when I'm really thinking hard, is I start to talk to myself out loud. Try to drop those extra senses to help with the brain power. Or your visual or audio. I think or both. You're using both. If anybody can download the full version of Tableau, you can still use the credentials in your MySQL database to do that. I tested that earlier. your username and your connection information. That will still connect to the database. You can connect to the console schema with a downloaded trial version of Tableau Desktop and be able to draw those relationships. And that worked okay for me when I did all of that using the database connection. Just comes in a more straightforward format. And this is what the relationships look like, and it seems to work fine here. For sure. If I did publisher in North American sales, that worked okay. See all these from this data set was 2018. Almost still a bunch of publishers of games. So you can, since you have all these related to each other, you can start asking questions in a new way. So publisher by console. And that's really like the key of having it in a relational database, is to be able to do that. Good. Keep one, you can dive deeper on one. And let's see what were all of the titles here. I'm familiar with Bethesda, Fallout. They did Fallout games. I heard Skyrim too. Wolfenstein. Me, like SQL, like helps you really query around structured data fast, and then Tableau is awesome for exploring the data, getting your hands on the data.
Yeah, like whenever I used to just like
and visualize
numbers,
it.
I'm like, this is actually nothing to me. I can think about it. Yeah, seeing it as a chart helps so much.
Yeah, but purely just to obtain data in a structured way, SQL's awesome for that. Much better than having to bring it all together yourself.
Yeah, I think it's nicer to like narrow it down pretty quickly in SQL, so you just get everything you need, and then you can like Tableau rather than having to
That's what I would do.
Because like filtering kind of gets like sloppy, so like I could definitely see from doing something good. I was like,
you can always
hoping with how we can tie this with Tableau. So
yeah, we can always you can always edit views too, and then reuse views in other dashboards and stuff like that, which makes it really helpful instead of doing this in a single dashboard too. Try to reuse as much as you can.
Yeah, I can see too when you get used to like, my assumption is like you get over these reports like every week, every month, so you know what all the like columns are and all that stuff, and so you get used to like these are the ones I'm going to use and care. They give you the best information, so you can use it.
Yeah. Yeah, and sometimes they'll write business rules into views to you when it's like really easy to see it that way.
I really like too when you're putting the tables in and having to connect them and connect the similar names. It was kind of like similar to the ERD that you made, and so it was like being able to like make that connection. So it's almost like you can build the ERD in Tableau.
Yeah.
Too.
Yeah.
Or like verify them. I don't know. So it's like that was nice to kind of actually like do it in like a way.
Yeah. It's how I had reset myself, and then it's like, well, how would a data analyst really use an ERD? That would be the way to do it. building those relationships in Tableau or querying across it using SQL. Not usually constructing them yourself as much. Usually that's already done in whatever system you're using. You just have to figure out all the connections, how to get the data you need. All right. That's it for class. I'm here for another 30 minutes, of course, as always, to answer questions. But we're approaching our final class. Hopefully, you gain the information you need and the skills that you need to use SQL. At least get started using SQL on the job or wherever it might be. And then after that, it's all just building upon it and applying it. And hopefully, I'm doing some things to say what you would expect within if you went somewhere to work also. How about databases and then just data in general, with the last class being some more advanced things that I can familiarize yourself with that you may eventually use as your SQL skills grow.
So can you so we use SQL Workbench. Like, are there just like lots of platforms? Is it really just like there's lots of platforms you know either use SQL or use Python or whatever, so you can use the SQL language on a lot of different how do you know if I were to go in if they use SQL or I don't know.
Well, SQL's like a common language across like all the different databases or database management systems. They just have like their small differences. Like functions will probably be like one of the biggest differences. Like they'll be named something different in MySQL or like Microsoft SQL Server versus MySQL, but they have like similar. They'll have like similar ones.
But it won't be like here you use SQL, that's great, and then it's like a random platform that's like, well, it's like technically SQL, but it's like the most different things. Like it's all pretty similar. Use like the code can be different, things like that. But like that's always like
they may
be worried about a problem that doesn't exist.
So
what does happen?
MySQL Workbench is specifically for MySQL. Like I use Microsoft SQL Server a lot, and it's SQL Server Management Studio, but it's like the same idea is that you can look through like databases and tables, and you see all the database objects, and you have like a scripting pane, and you run it. Like they're all going to be like fairly similar. Basically, like the same, other than functions. Like if you know one, you know all of them.
Okay.
And that's just like a Google search away.
Okay, you wrote this, you know this stuff. Do you know this random thing? I'll be like, no.
I know they like to ask obscure things on IT interviews. You forget when you're an expert about maybe like I did with those diagrams, is like the level that other people are at, or taking it for granted that like other people already know it. I think
I'm a big person about like assumption of knowledge, like especially when I do like instructional design and like tech writing, it's like you can't assume people already know anything.
Yeah.
So, sorry.
See you, Melinda. So yeah, Carmen just asked a question if this will be on the recording. I'm still recording, so you'll be able to catch it and be able to, if you download your own version of Tableau Desktop, like a trial version, be able to connect to a database for 14 days Otherwise, I'll do some CSV files tomorrow and try to connect them myself, and maybe I just put the whole workbook out there that way. But feel free to try it yourself. It's kind of can ties everything all together here too, with all this work that we've done with SQL, and then how it ties into Tableau and how you might bring that data there. I think that's about everybody. Just called it good, but still here for 24 minutes. I'm going to go ahead and end the StreamYard video. For this class. All right. Right. So that ends this class number 7 for Omaha Data Science Academy for SQL 101, class number 7, with storing and managing data in the enterprise. The next lecture will be about advanced database functions. These include features like stored procedures, temporary tables, common table expressions, and building your own SQL functions. Until then, this is Jeremy Bergman, professor at Data Science Academy, and we will see you for the next class.